Variables and expressions. An algebraic expression is a mathematical phrase that uses one or more variables. A variable is a symbol, usually a letter, that represents a value. Really, in all of the problems that we're going to do, our symbols are going to be letters, our variables are going to be letters, but know that it could be a symbol as well. So an algebraic expression has variables, and then we also have numeric expressions, and a numeric expression is a mathematical phrase that involves numbers and operation symbols, but it does not contain any variables. So a numeric expression is a mathematical phrase involving numbers and operation symbols, but no variables. If it's an algebraic expression, it will contain variables. Some keywords that we're going to use to be able to write algebraic and numeric expressions for the operation symbols. Some keywords for addition would be sum, plus, a total, more than, or increased by. For subtraction, some keywords that would indicate an expression that has subtraction would be difference, minus, or less than, or decreased by. Something that's important about more than and less than, when we see the phrases more than and less than, we're going to switch the order that they appear. So if I say 5 less than x, that would actually be x minus 5, not 5 minus x. And we're going to do some examples of that here in just a second. The other ones for addition and subtraction, we would keep the order the same. So if I say the sum of 5 and a number, it would be 5 plus x. And like I said, we'll do an example here in a second. Some keywords for multiplication would be product, times, multiplied by, and of. And then the last operation that we're going to talk about is division. And some keywords there would be quotient and divided by. Those are mostly the ones that you're going to have division. If it's a fraction, remember multiplying by a fraction could be the same as dividing. So if you say like a fifth of a number, that could be 1/5 times x, or it could be x divided by 5. But that's actually the same operation happening. Multiplying by 1/5 is the same as dividing by 5. Some examples. It says, what is an algebraic expression for each word phrase? So A, we have 25 more than a number in. So more than indicates addition. This is one of the ones that I was just talking about on the previous slide. 25 more than a number, we're going to actually write the expression in plus 25. For addition, the order doesn't necessarily matter, so in plus 25 would be the same thing, would give me the same result as 25 plus in. But if it was subtraction, if it said less than a number, the order would matter. So anytime you see more than or less than, you're going to switch the order that they appear to write your expression. The next one says 74 less than a number in. So 74 less than a number in would be in minus 74. And there the order definitely does matter, because in minus 74 is not going to give you the same result as if you had 74 minus in. So 74 less than a number means start with a number and take 74 away, or subtract 74. The next example asks the same question. What is an algebraic expression for each word phrase? A is 5 times a number in. Times a number indicates multiplication, so it would just be 5n or 5 times n. And then B says the quotient of a number in and 7. Quotient means to divide. Leave the order the same, and that would give you n divided by 7. These were pretty basic one-step or one-operation problems. These next examples are going to be a little bit more complicated. This it says again, what is an algebraic expression for each word phrase? A says 4 more than twice a number x. So 4 more than means we need to end up adding 4. Remember, more than, we're going to switch the order, so 4 is actually going to come last. Adding 4 is going to come last. And then twice a number x means we need to multiply 2 times x. So the expression would be 2x plus 4. The next one, B, says 7 less than the quotient of 8 and a number x. So 7 less than means that in the end of our expression, we're going to end up subtracting 7. But we're taking 7 away from the quotient, which means to divide, of 8 and a number x. So the quotient of 8 and a number x would be 8 divided by x, and then 7 less than that would be minus 7. So we have 8 divided by x minus 7. The last example here says the product of 9 and the sum of a number x and 2. It's important here that you read this carefully. It says the product of 9 and the sum. So we are going to have parentheses around the addition problem here because we actually want to multiply 9 and the answer to the sum of a number x and 2. So we would need to do 9 times in parentheses x plus 2. 9 times the sum, x plus 2. The next example says, what word phrase can you use to represent the algebraic expression 4x? Pretty simple, 4 times x, right? So a couple of ways that you could do that. You could say the product, which means to multiply, of 4 and a number x. You could also say 4 times a number x, and you could also say 4 multiplied by a number x. You don't have to do all of those in your assignment, but just know that there are multiple ways to write the same expression using words. And the last example says writing an expression to describe a pattern. So it says the table shows how the cost of renting a scooter depends on how long the scooter is rented. What is the rule for the total cost? Give the rule in words and as an algebraic expression. So for 1 hour, it's going to cost you $17.50. For 2 hours, it would cost you $25. For 3 hours, $32.50. 4 hours, $40. And for 5 hours, it would cost you $47.50. So the question, the expression, is going to be, what can you do to the number of hours h to get the cost? Okay, so the first thing that you're always going to look for, because it would be the easiest, is if you can just add or subtract something to the hours to get the total cost. In this case, it's not going to happen, right? To get the cost from the hours, you can't just add or subtract an amount to the hours. Then you're going to check to see if you can just multiply or divide. Okay, no, you can't. 1 times 1750 would give you the 1750, but 2 times 1750 wouldn't give you the $25. So in this case, we know we're going to be performing 2 operations. If you look at this, you can find a pattern going down the cost. Every time you increase by an hour, you're going to add $7.50. So for each hour that you rent what are we renting? I'm sorry, the scooter, right? You're going to increase by $7.50. So 7.5 or $7.50 times the number of hours that you have the scooter, but then you're also going to need to add 10 to that. So your expression is 7.5h plus 10. And the way to say that using words would be multiply h, which is the number of hours, by 7.5 and then add 10. That means to rent the scooter, there's probably going to be a $10 charge just to get the scooter, and then it would be $7.50 for every hour that you keep it. And that's how you write expressions, algebraic expressions.